So we're going to start learning about completing the square, and today's going to be the first day we're going to do a couple days of the topic. Now the idea of completing the square comes from perfect square trinomials. So we're just going to review that really quickly before we start making them. Now what we have here as an example, perfect square trinomials are a special type of polynomial. So we looked at x squared plus 10x plus 25. When we notice the leading coefficient is a 1, we could ask ourselves what number multiplies to 25 and adds to positive 10. And that, of course, gives us the number 5 and 5. So if we have the same factor written twice, we can convert that to writing it like this. We have another example down here. What numbers multiply to positive 64 and add to negative 16? Well, that's negative 8 and negative 8. So since we have the same factor twice, we can write that factor to the power of 2. Now, they're called perfect square trinomials for a couple reasons. One, because when we write them, something is squared. But then also down here, they're called perfect squares because if we imagine them with algebra tiles, they make squares. That is, each side or each side length is the same. So in the example, I took x squared plus 10x plus 25. So we see our x squared. We see 5x's here, and we see 5x's here. And on the inside, we have 25 positives. Now, the last part of our review of these perfect square trinomials is just how we recognize them in their trinomial form, which is what I've included up here. Now, what they're asking us to connect is if we can see what's being squared in parentheses. So we'll come back and use this as our example. So here we have x plus 5. So in this case, the first thing was an x, and the second thing was a positive 5. They call them A and B. We're calling one of them X and one of them 5. And again, it's really nice to look at the term separators there so we can see that whatever was first and whatever was second. So the idea is we could use a pattern to help us expand these a little bit quicker. So in this one, if the first thing is X, we would take that first thing and square it, and that'd be our first term. So X squared should appear here. The term at the end would be the second thing, so in this case positive 5, but squared. So this is 5 squared, and this is x squared. And what they're saying in the middle is we take the two things that was in the parenthesis, so x and 5, we'd multiply them, and then double it. So if I took 5, and I multiplied it by x, and then I doubled it, that should be my middle term. So we'll do a quick example to see that pattern one more time, and we're just focusing on this pattern right here. So if we had to expand x minus 3 squared, this is a perfect square, so we'd identify what two terms are in the parentheses. So we have an x and a negative 3. So to expand it, the first term is whatever's first in the parentheses, but squared. So I take the x and I'd square it, and that goes first. I think it's nicer to go to the end here. So whatever's last is the last term, but squared. So I take that negative 3, and the entire thing needs to be squared. Now the number in the middle tells us to take the two things that were in our parenthesis. So in our case, one of them is an x, and one of them is a negative 3. And then we need to, since there's no plus or minus, that means multiply. We need to multiply them together and double it. So we'd put a 2 there. And simplifying this would give us our trinomial. So we have x squared. This term here is twice of negative 3x, which is negative 6x, and this term is a positive 9. It's just a fancy way of doing the FOIL method. It's just a pattern that they're noticing. The last thing to appreciate is why the 2, and just remember, if we have the same thing, if we make a square and both sides are the same dimensions, then we should get, over here, we get 2 groups of 5, or we get 2 groups of negative 3. So that's how we see that double. Now, the reason why we care is because completing the square is about creating a trinomial that would be a perfect square. But it also lends itself to a visual cue. So for instance, what we need to do right now, we're going to start with finding the correct C value that helps make a perfect square. Now, the reason we call it completing a square is you can see that below, down here, I've created our algebra tile. So we have 1x squared, and we have 12 x's. And what I've already done is grouped those 12 x's into 2 groups of 6, because we can see again from our pattern before that we should have 2 that middle term should be doubled, so 2 groups of 6 would make 12. Now what we need to figure out is what tiles would I put here to complete the square. Now what we know is that using our algebra tiles, if we were going to fill this in, we would have, or we could make a grid that was something like this. Now all we're doing is filling in how those algebra tiles meet. And if we counted those algebra tiles, what we can see is it's 1, 2, 3, 4, 5, 6 by 6. So this would be 36 algebra tiles. So if we did have the trinomial x squared plus 12x plus 36, we'd ask ourselves what numbers would multiply to positive 36 and add to positive 12. Well, I could factor that as x plus 6 and x plus 6. And of course, if I see the same thing twice, I could just write that base and square it. So by putting the number 36 at the end, we were able to take a trinomial and write it as something squared. Now let's see that again. So if we started a trinomial with x squared minus 6x, we would have to figure out what number would I put here to make it factor into something that is squared. So we want to complete the square, and what we could think about is how would I arrange those negative 6x's? So if we think about this as a picture, I would want to split those negative 6x's, into 2 groups of negative 3, because if I want to make a square, the side lengths need to be the same. So I'd want to have an x and a minus 3 on this side, and the same thing over here. So if I thought about filling in this little part here, or in other words, completing this square, I would be filling in something that was 3 wide by 3 tall. And I know a negative times a negative would equal a positive. So here I would have 9 positives. So if I put a positive 9 there, it would make sense for me to say that negative 3 times negative 3 multiplies to positive 9, and negative 3 plus negative 3 is negative 6. So I could factor this as x minus 3 and x minus 3, which is just x minus 3 squared. So in general, if we have a quadratic polynomial where the leading coefficient is a 1, or in other words, the a value is equal to 1, what we notice is whatever the b value that was given, like here it was 12 and here it was negative 6. The way that I arranged the algebra tiles was I took 12 and I put 6 of them here and 6 of them there. So I took 12 and I divided it by 2 to get 6 and 6. Over here, I had negative 6x's, and since I wanted to make a square, I needed to evenly distribute those x's on each side of the square, so I put negative 3 of them here, and I put negative 3 of them here. Or in other words, I split the negative 6x's into 2 groups. So in general, the number that fills in this blank is always going to be b over 2 squared. Now, why squared? Because when we created all the ones, we had the 6 by the 6, which gave us 36. Same thing over on this example. I took the negative 6x's and I split it into a negative 3 here and a negative 3 there. So when I created the square, to complete the square, negative 3 times negative 3 was positive 9. Now the next thing that we notice is when we factored this one, we put a 36 here, and this was factored into x plus 6 squared. Now where do we see the 6? Well, the 6 was us taking that 12 and dividing it by 2. Or in other words, we took our b value of 12 and we divided it by 2, and that gave us 6. And that's the number that I saw there. Let's look at the next example. This one, after we added positive 9's, we got x minus 3 squared. Now, where did we see the minus 3 come from? Well, same thing. That came from this, where we took our b value, which in this case was negative 6, we divided it by 2, and that gave us the number negative 3. So we can say we know what number fills in the blank, but we also can see a pattern. If we fill in the blank with b over 2 squared, then the number here is just b over 2. So we could factor it into x plus b over 2, and then x plus b over 2. And if we see that same thing twice, then we get x plus b over 2 squared. Now this formula is what you want to know. This formula works for trinomials with a leading coefficient of a 1 and a b value. Now we're actually going to do a full completing the square problem. Now what we see with completing the square problems is a lot of time we are going to start with trinomials already. So we do see that this one already has a c value. We were practicing before with ones that did not have a c value. So we are going to address that in our example today, but this is one complete example. So I have the directions on how to complete the square on this side. And what we're going to do is we're just going to pretend that that little -7 isn't there. So the first thing I recommend is setting up our workspace. Now what we're going to do to make it look a little more like the last examples we did is if there is an existing c value, like this -7, we're just going to move it way over to the side and pretend like it's not there and just deal with it later. So I'm just going to copy the x squared, copy the 4x, put that -7, I'm just going to shove over to the side and deal with it later. Now the reason we did that, which is our next step here, we're going to place what I call the placeholder. I just want you to put a line so it makes it look like the last problem. We're going to decide what number to put there. Now the last part about setting up our workspace is if we're going to put something on the right side of the equation, if we're going to put our own number here, we obviously have to keep the equation balanced. So if I'm going to put something on one side, I'd have to put it on the other side. So I'd also want to create a placeholder on each side. So if I added a line to one side, I should add it to the other side. Now our next step, number 2, is we're just going to focus right here because again, that looks like the practice that we just had before. We can figure out, sorry, I'm just going to put a little plus sign there. We can figure out what number to put here to make our perfect square. And we said the way that we do that is the number that goes there is always b over 2 squared. So in this case, our a value is 1, our b value is 4. So to figure out that special c value, we take b over 2 and square it. Or in other words, we take 4 and we divide it by 2, and then we'd square it, which actually gives us, so 4 divided by 2 is 2, 2 squared is 4. So I found the correct c value. I put a 4 there. I call it the correct one because I assumed that this -7 just wasn't the number that I wanted, and it was supposed to be a 4, not a -7. So I just moved it over and I put the number 4 that I wanted. Now, the most important thing now is step 3. If we put a positive 4 on one side of the equation and we want to keep it balanced, we have to add that thing to both sides. So if I put a positive 4 on the right side, I need to put a positive 4 on the left side. Now, the whole reason that we put a positive 4 was so this is now a perfect square trinomial. And the reason we made it a perfect square trinomial is because we know how it factors. So we're down here at step 4. We said before that it's going to factor into x plus b over 2 squared. And we figured out our b over 2 value, right? We figured this value out right here. There we squared it. We just don't want to square it. So b over 2 was 4 over 2. So I'm going to replace this with 4 over 2. Right, our b value is 4, we divide it by 2. And then of course I'm going to simplify 4 over 2 just to the number 2. Now everything else is the same. We're going to rewrite everything. So we still had a y plus 4 on the left side, and we still have this -7 over here. We haven't addressed that yet. But that brings us to step number 5. We just want to get y alone, and that's where the -7 is going to come in. So if I subtract 4 from both sides, I have y, and then equals. I still have this stuff, x plus 2 squared. And now -7 and -4 make a -11. And we are done with completing the square. We have made vertex form of a parabola. So what we could see is that since there's a plus 2 there, our vertex has moved left 2 and then down 11 units. So this parabola whatever it was, however it looks, I know the vertex is at -2, -11. Because if I took this vertex, or excuse me, this parabola, and I just do a bunch of work, which we called completing the square, I can rewrite it in a new form, which was vertex form. So let's do one more example. We're going to move a little bit quicker here just because we saw an example. So step number 1 that we're going to address is we are going to set up our workspace, which means this C value is probably not the number that we want to create a perfect square trinomial. It's not, right? We can't factor this as a perfect square trinomial. So we're going to pretend that that is just off to the side for a long time. So we're going to move that over, keep that +5. We're going to just copy everything else, x squared minus 6x. And we're going to give ourselves some space to add our perfect square C value. And then if we're going to add something to the right side, we would need to add it to the left side. So I create a little space for that later. Now step number 2 is we need to find the correct C value. And remember, the correct C value we always find by doing b/2. And then we square it. So I like to show my work in 2 steps. So if I took my b value, which is -6, and I divided that by 2, that would give me -3. So then in the second step, b/2 squared would be -3 squared, which is just 9. So I know that if I put the number 9 here, this trinomial would be a perfect square trinomial. And if I added 9 to the right side, I need to add a 9 to the left side. Now in step number 3, all we have to do, excuse me, that step was step number 3. We added that to both sides. Step number 4, we want to factor the perfect square trinomial part. So in other words, what we said was, if we create a perfect square trinomial, it should always factor into x plus b/2 squared. So our b/2 value was -3. So in our parentheses, we would have x -3 squared. I would also point out, don't forget, this is just a regular trinomial. What numbers multiply to +9 but add to -6? That's -3. So if you need to show an intermediate step because following that pattern is a little bit tough for you, there's nothing wrong with that. Now, after we factor the trinomial, everything else is still there, right? That +5 is still hanging out on the right side. And on the left side, we still had y, and then that +9 that was there. So our last step, number 5, is to get our y value alone. So we have our equation, or just y equals something. So I'd want to subtract 9 from both sides. So I have y, this part is still there, x minus 3 squared. And now +5 and -9 would combine, and there'd be 4 more negatives. So this is vertex form of the original equation, or the original parabola, x squared minus 6x plus 5. So using vertex form, this vertex must have moved right 3 and down 4. So we'd be able to say that this parabola has a vertex at the point 3, -4. And the very last thing is a great way to show your teacher that you've watched the video and that you've taken complete notes. What I want you to remember is completing the square is a method to write vertex form of any parabola.